Welcome to Chemistry 2, Unit 2 on thermochemistry. This is Lesson 3 on thermochemical equations, Video 1. So in the reading, you read about what a thermochemical equation is, so we're just going to review that material. A thermochemical equation is a balanced chemical equation, so we have already balanced using coefficients with a given delta H value. And a delta H value is a change in enthalpy. And enthalpy for our purposes is just a fancy word for heat. So we can have different types of delta H values depending on what is going on in our equation. So our first one we're going to look at is a delta H RXN, and RXN is just an abbreviation for reaction, and I'll be using that throughout this unit. So this is read as a change in enthalpy of reaction. And this is defined as the heat absorbed or given off by a reaction with the coefficients as written. So with our balanced coefficients, so that's what's really important. So it's for as the reaction as it is written. In these physical states, so solid, liquid, gas, aqueous, are important because if we have a phase change, we know that that involves heat. So whether something's a solid or liquid, it's going to contain more energy, more heat. And if we have delta H positive or delta H negative, that tells us whether heat is absorbed or given off. So a positive delta H, heat is absorbed. That means that it is endothermic. Delta H negative, heat is given off, which means it's exothermic. So those really haven't changed. The same thing with Q when we were talking about heat with Q, positive and negative told us whether it was endo or exothermic. Now, on this, we also might see a little degree sign as a superscript on the H. And the X there just stands for any subscript. It could be reaction. We're going to see other ones too. But that little degrees reads as a prime symbol. So we'd say delta H prime sub X. This means that we are at standard thermodynamic conditions. Because heat can change based on pressure, temperature, all of those things, we actually have standard conditions so we can calculate things and be on the same playing field as everybody else. So these standard conditions are 1 atmosphere pressure and 25 degrees Celsius, which is 298 Kelvin. And that is approximately room temperature. So that's why they use that value. So if we had delta H prime of reaction, that means that we are at standard conditions. And our units are going to be kilojoules per mole reaction. So kilojoules per mole reaction.